Are you an Archviz artist struggling with path tracing in Unreal Engine 5? If you give me 45 minutes or less, I will show you my path tracing secrets that you won't find anywhere else. Hi, and welcome to my YouTube channel. If you're new here, I'd like to introduce myself before we dive deeper into today's video. My name is Rotimi Sariki. I'm a Nigerian-American 3D architectural designer and illustrator, and I've been working in the 3D industry for over 13 years. I started my career as an AutoCAD draftsman before transitioning to 3D visualization in 2012. I've worked for firms like Raphael Vignoli Architects and HOK. My main focus on this channel is architectural design and visualization through the use of Unreal Engine. If this sounds like something you'd be interested in, consider subscribing to the channel so you can follow my journey as I explore various design concepts and some of the techniques I use in my 3D visualization process. If you're watching this video, it means you've struggled with path tracing in Unreal Engine 5. If you haven't, you will. Listen. The reason why you've chosen to render your architectural visualization scene in Unreal Engine 5 is because you think it's the best tool for you. It's not a one-trick pony like many other real-time rendering software available today for architectural visualization. And if you're serious about being a pro in the architectural visualization business, you shouldn't waste your time with things like D5, Twinmotion, or Lumion. Let me explain. My viewpoint may seem contentious to you, but I'd like to ask you 3 questions. Is 3D visualization a hobby to you? Do you want to make 3D visualization a career? How are you planning to maintain longevity in 3D visualization? If your answer to question 1 is yes, then my strong advice to you would be to stop watching this video because the rest of the information I'm about to share in this video will be a waste of your time. If your answer to questions 2 and 3 is yes, then the rest of the information in this video is for you. I have been able to maintain career longevity in 3D visualization because I always look for a tool that checks all 3 of these boxes. 1. Easily accessible. 2. High rate of global professional adoption. 3. Difficult to master. And 4. Market sector adjacency. Right now, Unreal Engine 5 checks all these boxes, and I think you should strongly consider switching over to Unreal Engine 5 for your 3D visualization projects. So, let's break these points down one by one so you can get a better understanding of the points I am trying to give you clarity on. Easily accessible. Unreal Engine 5 is free to download and use for personal projects and learning. There are abundant online resources, tutorials, and a supportive community, making it easy for beginners like you to get started with. High rate of global professional adoption. Unreal Engine 5 is used by tons of professionals in all sorts of industries: game development, architecture, automotive, and film. It's so popular that the skills you learn are in demand everywhere and can be used in lots of different fields. Difficult to master. While Unreal Engine 5 is accessible to beginners, mastering the core concept and its adaptability to other relevant areas and aspects of 3D visualization will take you years. This is the key component that will make you stand out from the rest of the crowd who just want to do traditional 3D visualization work in tools like Twinmotion, D5, and Lumion. Being a generalist will open more opportunities for you. Trust me, my career achievement so far is living proof that what I am saying has validity to it. Which now brings me to the last point. Market sector adjacencies. Because Unreal Engine is so versatile, you will be able to readily transfer the skills you've mastered across multiple industries where 3D visualization skills are relevant. If you currently work in architectural visualization, most of your exterior 3D visualization skills can be transferred to making 3D environments for games and virtual production sets for films. Think about that for a second. If you only learn tools like V-Ray, D5, and Lumion, the transition for you will be extremely difficult. So right now, Unreal Engine 5 checks all these boxes, and I think you should strongly consider switching over to Unreal Engine 5 for your 3D visualization projects. With that being said, let's now jump back to the main topic of this video, which is path tracing in Unreal Engine 5. So, what is path tracing? Path tracing is an advanced rendering technique that simulates the way light behaves in the real world, producing incredibly realistic and accurate images. This video will walk you through the basics of setting up and using path tracing in Unreal Engine 5. If you've previously used V-Ray GPU on some of your projects, path tracing in Unreal Engine is similar to GPU rendering with V-Ray. Unreal Engine's path tracing feature shares similarities with V-Ray GPU's rendering, making it a potentially easier transition for users like you who are already familiar with V-Ray GPU. Unreal Engine and V-Ray both leverage the power of the GPU to accelerate rendering calculations and produce high-quality images and animations. Path tracing in Unreal Engine, like V-Ray GPU, accurately simulates light transport, including global illumination, reflections, and refractions. This results in photorealistic images with realistic lighting and shadows. Additionally, both rendering solutions offer progressive rendering, allowing users to preview the image as it renders and make final adjustments in real time. For those familiar with V-Ray GPU's workflow and interface, Unreal Engine's path tracing may present a less steep learning curve due to conceptual similarities between the two. However, it is important to note that while there are parallels, there will still be differences in specific features, settings, and optimizations between the two rendering engines. Now, let's talk about how to enable path tracing in Unreal Engine 5. To enable path tracing in your Unreal Engine 5 project, take the following steps. Step 1. Open your Unreal Engine 5 project. To do this, you can either open the Epic Games Launcher, click on the Library tab, and click on the icon representing the project you'd like to open. Or, you can use Windows File Explorer to open the location where your Unreal Engine 5 project is stored, double-click on the .u project representing your Unreal Engine 5 project, and wait for the project to load and compile all the shaders needed to open the project. This step assumes that you have already installed the Epic Games Launcher and a 5.0 and above version of Unreal Engine 5 on your workstation or computer. Once this project is open, go through the following steps. Step 2. Access the project settings. To do this, you can do this by navigating through the top menu and selecting Edit and Project Settings. Once you've located the project settings, the next step is to locate the rendering section. Within the rendering section, you'll find all the aspects you need relating to rendering. Step 3. Locate hardware ray tracing. Inside the rendering section, look for a category labeled hardware ray tracing. Step 4. Enable ray tracing. Within the hardware ray tracing settings, there will be an option to enable hardware ray tracing. Make sure this option is checked. Please note that you might need to restart the Unreal Engine editor for this change to take effect. By following these steps, you should be able to enable and utilize path tracing within your Unreal Engine 5 project. Remember that path tracing can be computationally demanding, so make sure you have a workstation that has a GPU that is compatible with ray tracing like NVIDIA RTX GPUs. Based on all of my testings, any NVIDIA RTX card 2090 and above can perform path tracing calculations. Let's now take a look at a practical example of how to implement all these steps that we've discussed so far. As discussed earlier, the first thing you'll need to do is to open your Unreal Engine 5 project. I'll go ahead now and open one of my completed projects in order to show you how to set path tracing up. The next thing we'll do after setting up path tracing in our project will be to take a look at some of the key settings you need to look out for in your post-processing volume and your movie render queue settings. We'll also dive into some of the console variables that will make it easier for you to render your animations with path tracing. If you prefer to just get your hands on the project files of this exceptional demo scene you're seeing on your screen right now, head over to my website via the link in the description of this video to get the project files. If you're looking for a free Unreal Engine 5 scene, comment free UE5 scene below and I will send you this scene free of charge. Now let's get back to the video. Now that we've gone ahead and opened our project, the next thing we want to do is just to make sure our project is active. Since our project is active, now we're going to go to the top menu and say Edit, and then go over to Project Settings. Once we get into the project settings, we're going to look for a section called Rendering. Once we click on the Rendering section, now we want to look for a section called Hardware Ray Tracing. Under Hardware Ray Tracing, we have multiple options here. The very first option is Support Hardware Ray Tracing. Please ensure that this option is checked. And then the next section is Ray Trace Shadows. Make sure that is checked as well. And what you want to look for is your texture LOD and make sure that is checked. And then the last thing you want to do is to make sure path tracing is checked as well. Once you've enabled all the key settings we talked about under hardware ray tracing, and you've restarted the Unreal Engine editor, you should have everything you need to start using path tracing in your Unreal Engine 5 project. The next thing I'll do now is to show you how to activate path tracing in the project I currently have opened. To do this, I'll move my mouse cursor over to the drop-down menu button next to the perspective button called Lit. Once your mouse cursor is over the Lit button, click on it to reveal the list of other buttons. Within the drop-down list, look for Path Tracing, move your mouse cursor over it, and click on it. You should immediately see the rendering process start in your viewport. If all you're looking to generate is a still frame image, wait for the path tracing calculation to finish and then take a high resolution capture of your viewport. If you're looking to generate nicely rendered animation through path tracing, the next section of this video will give you an in-depth step-by-step look at how to achieve that. Now that you've decided that your goal is to render out an animation sequence using path tracing, I'll go over all the things you need to make that happen. In order for me to keep this video from getting too lengthy, I won't be diving deep into all the camera settings and post-processing settings. Before we continue, I'm going to assume you've created your scene and have your lighting set up the way you want it. Now, let's add a camera to the scene. Because I already have a camera in this scene, I won't add another camera. With the camera selected, go to the Details panel. Once you find the Details panel, scroll down until you find the Post-Process section. Under the Post-Process section, look for a section called Path Tracing. Under the Path Tracing section, let's enable the max bounces, samples per pixel, max path exposure, emissive materials, and the denoiser checkbox. We will keep the default values of these parameters as is for now. Later in this video, we'll use an empirical approach to analyze some of these values and how they affect the final results of our rendered frames. The next step will be to create a level sequence and add our camera to the level sequence. To create a level sequence, move your mouse cursor to the clapperboard drop-down button, which is to the left of the green play button, and click on it. Look for a button called Add Level Sequence and click on it. You should see a new window pop up asking you to pick a location where you want to save the new level sequence asset. Once you've saved the level sequence, a new window will pop up. This is where you will add your camera actor and edit your animations. To add a camera to your sequencer, select the desired camera and then go to the sequencer window. Click on the green plus sign Add button next to the Search Tracks bar. You will get a list of other buttons. Hover your mouse cursor over the button that says Actor to Sequencer. It will reveal an option to add the selected camera. Once the camera has been added to the sequencer and you've created your desired animation, we'll set the frame rate of the sequencer to 24 FPS. This is typically what I use and it is a personal preference. Since I already have a pre-made level sequencer in this project, I will open it now. This is the sequencer I will be using for the rest of this video. Let's scrub our timeline forwards and backwards to make sure everything is working properly. Everything looks good. The next thing I'm about to show you is often missed by a lot of people. It is typically because they don't render exterior animations with lots of moving vegetation using path tracing in Unreal Engine 5. Find and select the camera actor in your sequencer. With the camera selected, go to the Details panel and look for the Rendering Features section. Under the Rendering Features section, look for Motion Blur. Under the Motion Blur section, we'll need to change two things. The first thing we need to change is the Motion Blur amount value from 0.5 to 1.0. Next, we'll change the target FPS from 30 FPS to 24 FPS. This is because we want the FPS value of our camera to match that of our level sequencer. If you want to achieve the same incredible results I've been able to achieve in my foliage movement, this is one of the key settings you'll need. Now that we've gone over some of the camera settings you'll need before you're ready to generate the image sequences needed for your animation, let's take a look at the post-processing settings. As mentioned previously, I will not be diving deep into other post-processing settings in this video. I am only going to focus on the settings we need for our path tracing animation. What we need to do now is to select our post-processing volume, go to the Details panel, and go to the Rendering Features section. Under the Rendering Features section, look for Path Tracing. Under Path Tracing, enable Max Bounces, Samples per Pixel, Max Path Exposure, Emissive Materials, Reference Atmosphere, and the Denoiser checkbox. Please note that these settings are also available in your cinematic camera actor as well. If you've already enabled these features in your camera, you may only need to enable the Reference Atmosphere feature by checking the tick box next to it in the post-processing volume. Let's now take a look at how to set up the movie render queue and all the settings you need to get a noise-free rendering. Let's first make sure we have the movie render queue enabled in our project. Go to the top menu in your Unreal Engine editor and click on Edit. You should get a drop-down menu. Look for plugins at the very bottom of the drop-down list and click on it. You should see a new window pop up. In the search bar of the new window, type Movie Render Queue to look for the plugin. You will get 3 plugin options. Enable the first 2 by clicking on the checkbox next to them if they're not already enabled. Please note that you may be required to restart the Unreal Engine editor after enabling these plugins. Once the Movie Render Queue plugin is enabled, we can now open the Movie Render Queue. We'll do this by opening our sequencer if we don't already have it open, and then click on the clapperboard button next to the camera button. You should get a new window that says Movie Render Queue at the top left hand side of the window. Now go to the Settings tab in the new window. Under the Settings tab, you should see a clickable button called Unsave Config with an asterisk next to it. Click on that button. You should now see a new window pop up. To save some time, I will now load a pre-configured render settings that I saved previously by clicking on the drop-down list on the top right corner of this new window and select my render preset. Now that the render preset is loaded, let's now take a look at some of the important settings you need for your animation. At the very top left hand corner of the window, you'll have a green plus sign button that you can use to add more features to your render settings. Let's take a look at some of the features I have enabled in my rendering preset. The first one would be under exports. I typically use an EXR sequence instead of a JPEG or a PNG. If you select the EXR option, you can change the compression method from PIZ to any other compression method of your choice by using the drop-down list. My preferred choice is DWAA, but you can experiment with other options to see what works best for you. My reason for using EXR is simple. I want flexibility in the color information of the rendered sequence when I do my post-production work in DaVinci Resolve. The next section is rendering. This is the section where you can add either the deferred rendering method or the path tracing method. I've opted for the path tracing method since that is my focus for this video. With the path tracer option selected, go over to the right hand side of the window and enable reference motion blur. This will help improve your motion blur quality if you have moving objects like leaves and trees in your rendered image sequence. Please note that this option needs to be used in conjunction with your temporal sample count under your anti-aliasing setting option. We're going to discuss it in a moment. All the other features under your path tracing setting can be left in your default state. Let's move on to the settings section. Under the settings section, we'll take a look at the anti-aliasing settings. First, we'll take a look at the spatial sample count. This number is basically used by the Unreal Engine to determine how many frames it needs to blend together before contributing it to one overall sample. It will essentially let you have better anti-aliasing quality. Based on my testings, a number between 64 and 128 tends to work really well for exterior visualizations with lots of good foliage assets. The next thing we'll look at is the temporal sample count. The value here determines the number of frames that Unreal Engine needs to combine together to produce each rendered frame. It is essentially what impacts the quality of your motion blur. Remember when we talked about reference motion blur earlier? Increasing this number in combination with enabling the reference motion blur setting under the path tracer feature and taking a look at your camera shutter speed will ultimately help with the quality of your motion blur in your rendered image sequence. Based on my experiments, a value of 8 seems to be the sweet spot for the temporal sample count. Please note, if you decide to increase the number beyond the value of 8, your rendering time will most likely increase drastically. I typically set the anti-aliasing method to none, and I don't make any changes to use camera cut for warm-up or render warm-up frames. Under advanced, I set my render warm-up count to 120 and the engine warm-up count to 120. We can now move on to the console variable settings. Console variables are essentially override commands that the engine will execute at runtime. This is important because the movie render queue is essentially a runtime application inside the Unreal Engine. Unlike your traditional render engines like V-Ray, when you hit render local on your movie render queue, it basically simulates a game environment based on the rules you've put in place in your game mode, which is under your world settings. I know this may be a little too complex for a path tracing video, but if you're interested in creating more complex visualizations like what you're seeing on your screen right now, you can book my time on my website where you'll get up to 8 hours of my time per month at an affordable rate. Let's get back to our discussion. I have a list of console variables here, but I'm only going to talk about 3 console variables. If you want a list of console variables that I use, there is a link to a downloadable text file that you'll be able to use on your own project. Let's get back to those 3 console variables I'd like to touch on in this video. The first one is r.screen%. I usually set the value between 150 and 200. Please note that if you have an NVIDIA RTX GPU that has a VRAM less than 12 GB, you will crash the Unreal Engine if you use the r.screen% value higher than 150. The next one is r.pathtracing.denoiser. This one basically helps you turn the denoiser on or off by changing the value from 1 to 0 and back to 1, depending on what you need. There are certain situations where you may want to use the denoiser. This console command gives you the flexibility. The last one we'll talk about is r.pathtracing.filterwidth. This is one of the best ways to control anti-aliasing and get a more detailed definition in your final rendered sequence. Its default value is 3, but if you want a sharper image, you can use a lower number. Please note that using a lower number could result in unwanted artifacts, so it is best to experiment with the values until you find the one that is best for the scene you would like to render. What if you've followed all the steps I laid out for you in this video and you realize it doesn't fit the rendering situation you're facing? Remember how I mentioned the empirical method earlier? If you don't remember, that's okay. The goal in this section of the video is to help you figure out what dials you need to push and pull in order to get better results with path tracing in Unreal Engine 5. Okay. Let's go back to our scene and select either the post-processing volume or the camera you've placed in your sequencer of choice. I'll go ahead and select the camera placed in the sequencer I have in the project I currently have opened. With the camera selected, let's go to the Details panel. Inside the Details panel, we'll look for the Path Tracing section so that we can start analyzing some of the available options and what happens when we change the numbers. By now, some of these path tracing features should be familiar to you because we've highlighted them multiple times in this video. The first 2 parameters we're going to take a look at are our max bounces and sample per pixel values. Let's set the max bounces to a value of 8 and the sample per pixel to a value of 512. We are going to leave the max path exposure at a value of 30. This value will remain the same for all of the tests we're going to run. Now, open the movie render queue again if you don't already have it opened. As previously mentioned, you can open the movie render queue from your sequencer by clicking on the clapperbot button on the right of the camera button in the top left corner of the sequencer window. With the movie render queue window opened, look for the Settings tab. Under the Settings tab, click on the Unsaved Config button. You should now see a new window pop up. This is the settings window where we will change a couple of parameters before we run the first test. I will load my pre-configured rendering preset to save some time. With the movie render queue settings window open, select the anti-aliasing setting on the right side of the window. Over on the left side of the window, look for a parameter called Spatial Sample Count and enter a value of 1. As mentioned earlier, the spatial sample count is the parameter that governs how many frames Unreal Engine will combine together before contributing it to one sample. It is essentially what controls the anti-aliasing quality. Let's now take a look at the temporal sample count. We'll change the number from 8 to 1. When you change the value of the temporal sample count to 1, you will need to uncheck the Override Anti-Aliasing checkbox if you already have it checked. These are all the settings we'll need to change in the movie render queue for our very first test. As you can see, our first results are in, and they are less than acceptable due to the rendering artifacts and noise we can see in the final image sequence. In this test, I changed the max bounces to a value of 32 and the sample per pixel value to 4096. The results look similar to the previous image sequence with no visible changes. This should let you know that when it comes to path tracing, the value of the max bounces and the sample per pixel are not the ones you should fuss about if you're looking to get noise and artifact-free rendering. For our next test, I will go to my movie render queue settings and change the temporal sample count value to 8 and leave the spatial sample count value at 1. We can see that the quality of the final image sequence has improved. However, the rendering time has increased by a multiple of 4. If you're rendering in 4K resolution, the best thing to do is to start with a temporal sample count value of 1 and a spatial sample count value of 1 as well. This will help you figure out the baseline for the amount of time it will take Unreal Engine to finish rendering all the number of frames in your sequencer of choice. For the final test, I will set the spatial sample count to a value of 128 and leave the temporal sample count value at 8. As you can see, the results were much improved and the rendering time increased as well. For most of your interior architecture visualization scenes, you don't need to increase your temporal sample count beyond a value of 4. When you reduce your temporal sample count for interior renderings, you should increase the spatial sample count so that the combined sample count of both the spatial sample count and the temporal sample count yields the same value. I will break this down a bit if the logic seems confusing. Let's say we start with a spatial sample count value of 128 and a temporal sample count value of 8. The total sample count for the final rendered image is 128 multiplied by 8, which will give us a value of 1024. If you now decide to reduce the temporal sample count to a value of 4 because you're rendering an interior architecture visualization scene with little to no movement except your camera, you will need to increase the spatial sample count to a value of 256. For those of you who like mathematical formulas, we can express it in this way. Let's call the spatial sample count SSC, and we'll call the temporal sample count TSC. The total samples per frame equals SSC multiplied by TSC. Now, if we divide TSC by a value of 2, we will need to multiply SSC by a value of 2 to keep the total sample per frames the same. Now, let's talk about path tracing for exterior visualization. The same rules we just talked about will apply here as well, with one exception. You must try as much as you can to never let the temporal sample count exceed a value of 8. Based on my testings, increasing it beyond a value of 8 will increase the rendering time drastically. By now, you should be feeling a little more confident in your ability to craft your next incredible animation in Unreal Engine 5 using path tracing. But before I sign off on this video, I'd like to do a recap on some of the things we've learned so far. 1. How to enable path tracing in Unreal Engine 5. 2. Key settings for path tracing. 3. Optimizing path tracing for performance. 4. Comparison between path tracing and rasterization. And then 5. My final thoughts and advice for Archviz artists jumping into Unreal Engine 5. To enable path tracing in Unreal Engine 5, you'll need to load your Unreal Engine 5 project. Go to the project settings and then find the rendering section on the left side of the project settings window. Once you select the rendering option, you'll need to find the hardware ray tracing section on the right side of the project settings window. Under the hardware ray tracing section, you'll find the checkbox for path tracing. Check the box. You will be prompted to restart the Unreal Engine editor. If you go through these steps properly, you should be able to start using path tracing on your Unreal Engine 5 project. There are several important settings that affect the quality and performance of path tracing in Unreal Engine 5. Samples per pixel. This determines the number of light paths traced for each pixel. Higher values result in less noise and more accurate lighting, but also increases render times. Maximum bounces. This controls how many times light can bounce off surfaces. Higher values lead to more complex and realistic lighting, but also increases render times as well. Spatial sample count. This is the number of frames Unreal Engine needs to combine together before contributing it to one sample. Adjusting this value will help improve the anti-aliasing in your still image or image sequences. Temporal sample count. This is the number of frames Unreal Engine needs to blend together to produce one frame. Adjusting this value will help improve the motion blur quality of your final image sequence. Filter width. This affects the smoothness of the final image. A higher filter width can reduce noise but also blur fine details. Let's discuss this a bit further so you can get a better idea of how this will affect your render output. One of the best ways to enable more control over the filter width adjustment in your final renders is to add the console variable to your movie render queue settings as r.pathtracing.filterWidth. The purpose of the console variable is to control the anti-aliasing filter width in the path tracing rendering system of Unreal Engine 5. This variable setting is specifically used for adjusting the quality of anti-aliasing in path trace renders. The value of this variable is set using a console variable system. It's initialized with a default value of 3.0, which corresponds to a Gaussian filter with a standard deviation of half a pixel. You can modify this value at runtime through console commands or project settings. If you'd like to get more in-depth information about this, please head over to this link. I've also added the link to the description of this video. Now, let's talk about optimization. Path tracing can be computationally intensive, so it is important to optimize your scene for performance. Here's a list of things to consider. 1. Simplify geometry. Reduce the number of polygons in your scene where possible. 2. Optimize materials. Use simpler materials and avoid overly complex shaders. 3. Use level of detail. Implement LODs for your meshes to reduce complexity at a distance. This is not always possible due to the popping that may occur when the camera moves too far from the LOD mesh. It is important for you to determine your camera movement and its distance from the mesh so you don't get unwanted artifacts in your final image sequence. Here is a comparison of path tracing and rasterization. If you're trying to determine the best approach for your project, it is best to consider your final outcome, the specifications of your workstation or computer, and other resources available to you. If you find yourself still struggling to justify using path tracing over Lumen, stop. The goal is always to generate the best image and animation possible. For many years, Unreal Engine could not match some of the popular offline rendering engines out there, but path tracing has put the power in your hands. Why would you want to use anything less than path tracing for your architecture visualization animation? If you compromise by using Lumen over path tracing, others will create stunning images and animations with path tracing and they will get the jobs and projects that should rightfully come to you. But the choice is yours. Thank you so much for watching this video. If you've really enjoyed this video, let me know in the comment section. And if I've helped you, do me a favor by liking and sharing this video. And if you're not a subscriber, what are you waiting for? Hit that subscribe button now.